Okay, so like that. I have done it as count, whether it is count. So yes, perfect. So now we can see that after undersampling, the data in the both classes is 1869 and 1869 perfectly balanced. But what is undersampled now? We are left with a which has a low. So now let us run see the code. Run the regression. Now we're going to code it. So applying the weights. So we are passing here -1 because it is without weights. So we are going to use the logistic regression without weights. So that is why we are passing -1 to our weights. Now we are going to train. Now what we do when we see yes and no, we are changing it or zero so that to calculate and classify also. So uh, we are changing the yes to one and no to zeros. Further, so let's go further. Now we are going to do the train test split, splitting the data. Right now training values. Now if we see closely, then the value for the zeros is 4130 and the value for one is 1495. So we can see the huge difference between the two classes, and this is not going to give us a good prediction model in order to calculate the values further, like precisely. So there would be a huge difference in precision. So we are going to check this after making our model also. So we have made a model. Hmm. So on the basis of logistic regression, I have written this function, and yes, on on running this function, a model is created on the basis of logistic regression, and it predicts some values, and the values are. Okay, and the values are here. Yes. So basically, what we see, the precision in F1 score, and the difference you can see is that the precision for 0th class is 0.88 and for the 1 is 0.60, and similar for the X score. So there is a huge difference between the F1 score of 0 class and the F1 score of 1 class. So our main motive is to reduce this difference and maintain the accuracy as well. The goal. Sorry, we are going to do that. पॉज है, वहां तक कट मारना है. So now I have shown you the data set and shown you the training model and shown you the difference between the F1 score and the precision. So now we are going to balance the data, this imbalanced data sets. So the method one would be undersampling. This is a very famous method. I've explained it in the video also. So let us continue with that. So we are going to make a class. So basically what we are going to do here is that we are going to undersample the majority Now we are going to apply the smooth sampling. So the smooth method, for that we have to import a library, because it is of oversampling. It is a kind of oversampling technique only. So we will firstly import smooth, and then we are going to do the resampling of the minority class. So we are going to say that sampling strategy is minority, because we are sampling it to the minority class. Okay, now we are going to assign it to our new columns, new variables named as XSM and YSM, and we will say that smooth, it should be smooth dot sample. Okay, it was sampled in previous case, now it is resampled. So it is X, Y, and then we are going to get our Y value counts. So value counts. Okay, there is some mistake. The smooth. Okay. Now we can start dividing manner. Both has same number of records, that is 5163 and 5163. So our smooth is also working fine. Now we are going to model that is on logistic regression. So we are going to again copy from random oversampling. Okay, here is our, so here is our logistic regression model. So copy. And now let's check for the accuracy. So we are getting accuracy of 0.766, and the F1 is afterwards we are going to compare for and precision of all the models. Anyways, so we are getting, so if you and 0.78. So if you remember in the previous one also, it was almost the same. So now let's go ahead and for one more technique, and that is ensembling method. So what is ensembling method? The ensembling method is suppose we have an imbalanced data set, and suppose there is an imbalanced data set of 10,000 records, and we have 1,000 for no values and 9,000 for yes value. So what we are going to do, we are going to divide the 9,000 records into equal parts, let's say into 3 parts of 3,000, 3,000, and 3,000, and we are going to combine it with the minority class, and then train the data. And then after training the data with those different, suppose there are 3 models, so then after
average
So now in the method 4, we are going to use the ensemble with undersampling. So what we basically do, we get a ratio of difference in the both of the classes, and we are going to divide the oversample data into that number of classes, and we round it to the number of times we get the ratio, and we split the data into that many parts, and then uh, then according to that we are going to undersample the majority class and divide it into that many parts, and divide it into that many parts, and then we are going party class, and then we are going to the all of those combinations, and we are going to get a voting. So what the majority, go with that. Now ensemble method, we are first going to take the counts. So df dot shown dot value counts, because we have to get the ratio afterwards. So 5.74 is for the no class and 1869 is for the yes class. Now let us regain the original labels and features. So just do the X as, I'm not going to copy again. I'm just going to write the code. Yes. Why should everything similar? Again, splitting the data. That is copy only. So again, we have to split the data according to that. So let us go first. The status of my train value counts. So the difference, that is 4130 to 1495. Now what we are going to do, we are going to divide it into three. So three classes, and we are going to divide the training model, train test model into three models. So let's um, in the first model where class one will be having the because it is the minority class and it was already having the 1495 records, and we are dividing the majority class into three parts according to the ratio that we got, according to the rough ratio we can say we got in the model prediction, in the difference of the in the imbalanced data set. So we are going to differentiate it into three models. So add divide one. we try was the 4130. And prediction number 2. And here it is going to be the model number 3, prediction number 3, and model number 3. So let's run these one by one. This is also executed. This is also executed. So let us now see the length of the data set that we got in the predictions. So let us see length. So 07. Now length of so all the predictions will be stop same length. Now what are we going to do now? We are give the prediction and accuracy. Accuracy prediction. So